Oh, I forgot my shoes. I'll be around in the lab to help you guys with a couple of things. Yesterday during y'all's work time, I mentioned that there are a couple of secondary reactions that occur based on the product's form. So it has to produce one of these products for you to even consider that this would occur. So it has to produce carbon dioxide, or carbonic acid, sulfurous acid, or ammonium hydroxide as a product. And then what you do is go, what's so special about these? They're naturally just a little unstable in aqueous solution, and so they make a secondary reaction occur. So that's where you might get some bubbles, like carbon dioxide will form big fat bubbles. Ammonia smells like cat pee, okay? So it has an odor to it, despite it's not a gas, but it's still vaporizing. And then cyanic acid, hydrogen cyanide is how we actually call it in its gaseous or molecular form. And then hydrogen sulfide is how we call it in its molecular form as well. I know those are technically acids, but when they form gases, we actually don't name it like an acid. It's kind of weird. But do you guys know what hydrogen sulfide smells like? Rotten eggs. Just FYI. Fun facts for the day. Cat pee and rotten eggs. Cyanic or hydrogen cyanide is slightly toxic, so you won't be doing that one. Okay. So those are 3 things to think about. And then, at the beginning, this was what I had up. And it's because you have to think about the states of matter of compounds that are forming as a product. And these couple here up here in purple are what we call the driving forces of reaction. So if one of these things forms, a reaction has occurred. So we don't write NR for no reaction. So it makes sense, right? Precipitate, if it forms a precipitate, you guys are probably good at double replacements now, recognizing it's soluble or insoluble. That's going to force a reaction to occur. If it forms a gas, the gas cannot be ionized. That forces a reaction to occur. Weak acids and weak bases, we don't ionize to an appreciable extent, so it's like 1, 2, 3% ionization. So we say most of them are in their molecular form still. So if it forms a weak acid or weak base, it's forcing the reaction to occur. If it forms an elemental solid like zinc solid, that would be like a single replacement reaction, for example, where one of the metals get booted out. That will be forcing the reaction to occur. And then pure substances like liquid water. So did you guys notice there was one that formed liquid water? Okay, notice I didn't say aqueous water. Why can water not be aqueous? Say again? Emily, give me. Right, you can't dissolve water in water. Like, that can't happen. It is water as a pure substance. So if you write L behind that, that might force you to recognize it's not aqueous, so you can't ionize it. Though water itself has like a really, really low ionization rate, it does make H pluses and OH minuses in itself, which is why it's amphoteric, because it can act as an aster base. Most of it doesn't do that. Most of it's still in its molecular form. So if you're making any of these, it is not a no reaction. It will be a true reaction where you'll have an NIE left at the end. You saw a couple of those. So any other weirdo things you saw throughout your NIEs before I move on? Yeah. Mm-hmm. Do they form carbonic acid? Okay, then there's going to be the no reactions. I mean, like half of them, right at half of them are no reactions. Some of you guys took the first half or last half, you're like, I didn't get any. And the other person's like, I got all the precipitates. So you're probably seeing some misrepresentation based if you guys split those up. Okay. So let me show you what we're going to do in the back, okay? So that can... I'm not going to do this for you. I'm going to show you what we do first. Yeah. not hard. You barely even need a whole milliliter to fill up the entire, system that you need. So what I'm going to do is I'm going to take their petri dish lids off and invert them this way, and I'll pour some of the fluid in here, and you guys are just going to take what you need back to your station. And this is all you need. But as you go, one person's probably going to be dropping all the pints down to the counter. So the other person's going to be going bubbles, precipitate reaction. Bubbles, precipitate reaction. I want to give you the chance to see what's going on. Then, after you kind of see everything you need to see, of course, something's going to change odors. But you're not going to stick your nose up, smell it like that. You're going to smell hot things at once. So I'm going to give you a Q-tip and you can count the solution, and then waft it towards you to see if you smell those iconic smells that we're talking about. Okay? You will identify based on your observations what you knew was going to happen with certain reactions happening, and what you saw comparing those notes together. You see certain stuff start to happen, I think you'll pick up everything down. But you want to go back to your stations first. I'm going to probably just switch this way. Go to where you guys worked yesterday. Look at your NIEs first with your colleagues. And then I'm going note to self, you ready? Yes, you need all of the NIEs in your lab notebook by Friday. That means I'm taking the lab notebook. Okay? So if your partner wrote down some and you guys are kind of going back and forth during the observation side of things, you guys will have time. So try to get your lab done in class today to help you get your
Wait, I have a question. So, like, if I have an acid, that means that, but that doesn't also slowly going on. I thought she said that
You know how the microtiter train, follow. Yeah, you guys only with the partners you're working with. It's gonna take some time.
I just think
encourage you to do listen up 3, 2, 1, ready. Send one of your partners, and now this is in the same group you're working together because I want you guys to be a very, I want you to have a large role in this class. Having 5 to 11 will work. 2, 3 is the max. So I'm going to let you guys pick up your own little trays, and what you're going to do is you're just going to scoop in, grab your knife, suck up the fluid you need, and just drop it here. It's like a little, like a buffet line, okay? So you're picking up the 9 like us for the solution, bring it back to your table. So they are numbered, so just make sure you don't wipe off your Sharpies and make sure you don't wipe off the oil will affect your tongue. And then you'll come over and you at your desk, okay?
No, I think
Miss Enlow, pardon the interruption. Would you send Joy to the office and she return?
Thank you.
Thank you.